Section 2.6, Two Quantitative Variables, Linear Regression, Video 4. In the last video, we talked about interpreting slope and interpreting intercept, but in order to define what I mean by linear regression, we need to talk about something called a residual. On the board, you see a scatter plot, which is actually in the textbook. If you have your textbook, you can turn to page 128 and see this picture. It is not drawn exactly to scale, but it'll do for our purposes. We could interpret the intercept and we could interpret the slope. In fact, let's go ahead and do that real quick. The intercept is negative 36.8, which means if the approval rating was 0, this equation would predict a margin of victory of negative 36.8, meaning that they would have lost in a landslide. Does that make sense? Probably not, because again, be careful when you interpret the intercept, because usually it's not valid. The intercept is the predicted value of the response variable when the explanatory variable is equal to 0. However, you should not use a regression to make predictions about the response variable for values of the explanatory variable outside of the observed range of explanatory values. In other words, when we gathered this data, the approval ratings that we observed were down here, and that was 30, it was pretty low. It was 31. So the lowest approval rating that we observed was 31, and the highest approval rating that we observed was 70. Because 0 falls outside of that range of values, we shouldn't use this equation to make a prediction for when the approval rating is 0. But that's how you would interpret the intercept. The slope represents how much you can expect the response variable to increase if the explanatory variable increases by 1 unit. So in this context, if the approval rating increased by 1 percentage point, we would expect the margin of victory to increase by this amount. But what do I mean by residuals? Well, when you have a prediction equation, it does precisely that. It tries to predict what's supposed to happen under some given circumstances. For example, when the approval rating was equal to, and I'm grabbing some of the data off of page 127, when the approval rating was 62.0, we observed a margin of victory that was equal to 10.0. Now, where would that point be on the scatter plot? Well, 62 is here, roughly, and 10 is here, so it's actually below the line. So here's the point whose coordinates are 62.0 and 10.0. However, what would this equation predict when the approval rating was 62? However, we predict a margin of victory of, using the equation, let's substitute the approval rating that we observed. So negative 36.8 plus 0.839 times 62.0, and whatever that equals. Time to work out a calculator. All right, 0.839 times 62, and then we're going to subtract 36.8. The predicted margin of victory was 13.54. So what does that mean in this picture? That means if we were to go up from the observed value to the line, the point on this line above it would be 62.0 because it's the same approval rating, but 13.54 because that's what our equation predicted. I do want to make one quick change. I want to change this first word pair to black just for contrast. 62.0, 10.0 is what we observed. But the equation would have predicted this point here. A residual is the difference between what we observed and what we predicted. In fact, that's the definition of a residual. The residual for an observation on a scatter plot is the difference between what we observed minus what we predicted. And more specifically, the residual for an observed pair. So in this case, the residual for this point is the observed response value, the second coordinate that we observed, minus the predicted response value. So what would the residual be for this point here? Well, all we have to do is subtract the margin of victory that we observed minus the margin of victory that we would have predicted with the equation. We observed a margin of victory of 10.0, but we predicted a margin of victory of 13.54, and when you subtract those, you get negative 3.54. What that means is that what we observed was 3.54 below what we predicted or what we would have expected based on this equation. Then again, I knew in advance that this point was going to have a negative residual. In fact, most of these points have negative residuals except for 3 of them. Do you see the 3 points where the residual would be positive? It would be the 3 points above the line. In general, every point below the regression line has a negative residual because what we observed for the response value is lower than what the equation predicted. But every point above the regression line would have a positive residual because what we observed is greater than what we predicted. So that's all a residual is. It's what we observed minus what our equation would have predicted for a given explanatory value, and more specifically for a given ordered pair. So how can we use these residuals to define what we mean by a line of best fit? Well, we'll figure that out in the next video.